Hello, yeah. My name is Ice, and actually my name is very difficult. Yeah, my family name is Om, and the family name is very not common in the South Korea. So just call me Ice. And I came from the Chonnam National University. It's located in South Korea. It's southern South Korea. Yeah. Today I talk about the practical method of finding vulnerabilities in IoT. But actually, most of the listeners thinks that this topic is describing the finding zero day vulnerabilities in IoT. But today I'm not talking about the 0-day vulnerabilities. Yeah. Today I'll talk about the artifact in IoT device after the compromising the switches. Yeah. So today, first I'll introduce about our research center is SSRC, and next about talking about the smart home and the smart home vulnerability and the artifact, how to acquire the forensic artifact more efficiency. Yeah. This is my introduction, and today we came from 4 guys for today our research topics, and 4 guys today came here together. Yeah, and we are belonging to the System Security Research Center in South Korea. Yeah, and we are researching on the basically the critical infrastructure security, like as nuclear power plant or the energy sector. Yeah, and the vulnerabilities and IoT and smart city. Yeah, there are many researchers is conducting research on the specific research area. Yeah, and we have the this address, our homepage address, as you can see the more detailed research articles about when our conducted research area. Yeah, and then we are actually recruiting some more motivated international students hiring now. So if you have any intention for our lab, we have many funding to the international student. So I think that there it's first time to attend HITB, but I'm very exciting in here, and there are many students in interesting on the cybersecurity. Yeah. And then I'll talk about today's agenda. Yeah. First, I'll describe the smart home. Yeah, it's kind of IoT. Yeah. So as you know, the smart home like Samsung Smart Things or Xiaomi or the LG. Thank you. Is the market size is very increased rapidly. The annual growth is over 20%. And maybe, as you heard that the smart homes market major player, maybe Xiaomi. Yeah, Xiaomi is the big player in the worldwide, and especially in the Asia and Africa, the Samsung Smart Things the most major player in this area. Yeah. This picture is a Samsung Smart Things platform is the growth dominant player in this specific country. Describe it. Yeah. And this slide shows that the smart things, smart home infrastructure. Yeah. As you do that, there are smart hub, maybe like the AP access point, and there are many the smart sensor. Yeah, smart switch and camera and sense and bulb. Yeah. Smart meter, yeah. And most of us use the smart home using the application, yeah. Xiaomi Mi or Samsung Smart Things like this. And most data is stored in the cloud based, yeah. So our research is focused on how can we collect the artifact for the compromised data, yeah, when the smart things is compromised, yeah. So most of data is closing maybe in the cloud, yeah, and maybe stored in the application. And as you know, the sensor is very lightweight device. So this device cannot store the huge data, yeah. So our next question is that maybe the smart hub is collecting the data between the sense and the cloud. So, we are the research concern is about mainly about the smart home. How do we collect the smart home data? Yeah. Next session is about the smart home's vulnerability. Yeah, as you know, there are many the CVE, common vulnerability exposure about the smart home device. Maybe the smart meter, Google Home meter, or the Apple router. And there are intrusion type is the DOS, denial of service, or phishing, or sniffing, or spoofing. Yeah. And as you may, most of us heard about that, the Mirai botnet. Yeah. Mirai came from maybe 10 years ago. Yeah. But, Mirai bot, BOT is the very, very typical model in IoT. Yeah. So this slide shows that, there are many kinds of specialized in IoT model device. Yeah. As you know, the Mirai botnet is very well lightweight by a model, but it generates many traffic messages over the network. So, it causes the denial of service, many devices. Yeah. This is the mechanism of the Mirai botnet. Yeah. Mirai, using the CNC, connected CNC and the scanning and the loader. Yeah. So, it can commanded by the same server, and it generated some more traffic to the other connected device. And last year, as you know, in last year there are many famous botnet. It's called the Moji. Yeah, Moji. Yeah. But Moji botnet is similar with the Mirai botnet, but it uses the blockchain. Yeah, the blockchain node. So it can evasion of some blocking mechanism. Yeah. So this slide, we have some concern point of how can it collect the artifact of the internal device? Yeah. So first is type of instance. Yeah. So how the device is just in compromise, or not just some disordering, was a malfunction. Yeah. So, and then the root cause. What is the root cause of this incident? And what is the connected systems to the other? Yeah. And second is device artifact. So when device is online, yeah, what data is collected from when this device online? And then we can follow up, shut down the device, and how can we collect the data? Call data, yeah. And morely hardware artifact. As you know, the embedded device security is very, very, highly, studied in this area, yeah. So, this is a hardware artifact device. So, we find the debugging port, like the JTAG or the UART, but nowadays, most of the JTAG port is protected by the manufacturer, yeah. So, it's not very easy to find out JTAG port, and we cannot, the debugging information. It's very hard to extracting from the debugging information, yeah. And then the memory dump, yeah, RAM or EPROM and the eMMC data port, we can extract more information, yeah. On next session, I'll talk about our research, some result for the smart home device. Yeah. So there are many smart home players, as I said, but we conducted the Samsung smart hub things, and the Xiaomi smart hub, and Arcade hub, and the HITB. This camera is very this camera HITB camera and the MV. Yeah. And next session, how do we collect the data acquisition methodology? Yeah. We are focused on 4 aspects. First is the physical hardware aspect. Yeah. As I said, from memory or firmware by the UART or the JTAG port. Yeah. And next is application. Maybe this application means that the application is installed in the smartphone. Yeah. So it's mobile application. As you know, there are many information storing our smartphone. Yeah. Actually, in Samsung, they use the SQLite DB. There are maybe 10,000, over than 10 tables. Yeah. SQLite DB is existing the Samsung Smart Things application. And maybe the Xiaomi using the, maybe the, NoSQL DB, like XML. Yeah. And then the network. Yeah. It means that it's very easy. Yeah. So we can capture the network traffic in that hub. But interesting is like that. Most of traffic is encrypted. Yeah. Maybe 5 or 10 years ago, we are conducting the cybersecurity for the smart meter in AMI in the electric sector. Yeah. But at that days, most of the communication like a ZigBee or the Bluetooth they don't have adapted the encryption. Yeah. But nowadays, yeah, most of the near field communication like as Bluetooth and NFC G-Wave is using the encryption. Yeah. So most of data is encrypted. Yeah. And next sector is OSINT. Maybe a little bit different OSINT, but we can use the open source intelligence. Yeah. So, first, the IDE. So most of the application is used, based on the cloud. So they offer some open API to developer. So we can collect the open API, interface. So we find some more, general data. Yeah. And the GitHub, like GitLab. Yeah. And there are some cases. What can you find from the OSINT? Is this is the smart things command line interface? In the command line interface, we can find more information about the device status and some artifact. But yeah, it needs account. Yeah, it needs some the CLI Samsung smart things account. It needs the account mechanism. So we are now finding some more bypass mechanism to bypass the account, the Samsung CLI. Yeah. And then this means that the CLI IDE, yeah, the Samsung things could offer the Groovy IDE to developers. So we find some mechanism and some parameter to handle the device like this. Yeah. So we find this information from the OSINT, like as the Open API. Yeah. Oh yeah, sorry. Yeah. And next step is we can find the artifact by the application status. Before we needed some smartphone routing. Yeah. Yeah. If we'll gather some more information by the routing status, and then gather data from the database or some files and the information like this. And this is the Samsung Smart Things, the SQLite DB. Yeah, there are many information like here in. And for example, there are maybe the camera status. Yeah, if the camera using the location, the location and some images. Yeah, this information is located in this like SQLite DB. Yeah. Yeah, this thumbnail images and thumbnail images of the data description is located here. Yeah. And this is the application, the status information, launch time and firmware information. Yeah. And the user information in here. And device event log information status. Yeah, like this. Yeah. This is a Xiaomi the application loaded, and Xiaomi is using the relational DB like the SQLite. They using the XML like the file database, and they storing the information like this. Yeah. And then the third type, the hardware component aspect is very, very important. It's very important and it's very, very, very difficult. Yeah. So first, the first stage is to identify hardware component. It means that, there are many components in the PCB. Yeah. So we find what's the components, the vendor and the model and the information. Like to make the BOM, yeah, bill of material. Yeah. And then we can find the data acquisition by the OSINT or by after desoldering and find the pin and extracting firmware, yeah, and like this. Yeah. This is a Samsung Smart Hub. Is the interface and appearance, and as you see, there are only the three interfaces: the exposed, its power, and the USB and the Ethernet. And open the cover, you watching some interesting interface, MPU, DRAM, and UART. Yeah. So first we can extract it. You can access the shell by the UART. Yeah. So we can access by shell by using using the shell. It's very difficult to find out what is the baud rate. Yeah. So we find the baud rate and the data bit and stop it, and this configuration. After that, we can connect the firmware or shell like this. Yeah. After access the shell, we can find some information like the firmware version or the other like the key, but it's not difficult to find the magic key. Yeah. You can find more information. You find the magic key. Yeah. Like I said, it's a similar Xiaomi Smart Home. Yeah, it's very similar. Yeah. And we can using the shell, official, and the command. We can find some command like this. Yeah. This is IeckChae Smart Home. Yeah, it's like very similar to the other product. Yeah. Yeah, it does this. Yeah, this information tell about how can you find this information. And maybe the IeckChae Smart Hub using offering the telnet service. Yeah, we can connect the telnet service by more get information like this. Yeah. This is the HITB camera. Yeah. I think that this device very, very vulnerable device. Yeah, in Thai. So actually in Korea, actually this device, this kind of device like came from China is very, very the concern point by national agency. Yeah. So last year we conducted some device from China, and we find many vulnerable data. Yeah. So this is this high vision camera, and we can find the firmware. Yeah, it's very easy. I think it's very easy to extract firmware in high vision. Yeah, and that we can find the flash memory type, and this is the information. Yeah, so we using the open source hardware like the Arduino. Yeah, so we find some converting the data to our analyzing machine. Yeah, so we can dump in the machine, and we can analyze the firmware level. Yeah. Yeah, this is MVR. Yeah, Hikvision. It's storing the data or the images and like this. Yeah. So we can, this device also we acquire the firmware and like the artifact, the data by UART. Yeah. Finally, I talking about the conclusion. There are many. It's not easy. Actually, it's not easy to find. It's not easy. Yeah, to extract all information from the device. As you know, the security agents and the manufacturer, they take many security control their device. So it's not easy. Yeah, compared than maybe 5 or 10 years ago. So nowadays, as you know, and then the most traffic is encrypted. Yeah. So it's not plain text, so we can find the information. So nowadays, most of research is focused on the artifact using the AI, like machine learning algorithm. Yeah. So nowadays we are conducting the data traffic analysis using the ML. Yeah. So we can capturing the near field communication by encrypted data and then classify the data stream. Yeah. By using the support vector machine and like as the classification algorithm. Yeah. As you see, the Samsung or Xiaomi is use the NFC communication, like as Bluetooth or the Zigbee. Yeah, so we can collect this NFC data from this device, and then we can classify this packet into the flow. Yeah. So we can find this first. What is the device using this our area? Yeah. First, and then we can classify the device manufacturer. So what device is the consist of our natural Hikvision, Samsung, or Xiaomi device? And then what is the major intrusion type, like DOS or the post scanning or the model, light model, like a botnet? Yeah. And there is what's the traffic type? Yeah. Maybe its traffic type means that the sensor mode, yeah, is a actuator or just only sensor or the image or video streaming. Yeah. So we are now conducting this research on our target device. Maybe so, in this maybe 2 or 3 months later, we can publish some research paper for about this research jobs. Yeah. Yeah, this is the end of my presentation. Yeah, so could we have any questions? Yeah.
There we go. Thank you, Ice, for a lovely talk. Does anybody have any questions? No questions? Okay. Can we then have another round of applause for Ice, please?
Yeah. Thank you. Yeah.